Okay, it's right about time. So you are all welcome to this general press conference, and a particular welcome to our Nobel Laureates of 2012 that are here on the podium and ready to answer our questions. I should introduce myself. My name is Staffan Normark, and I'm the permanent secretary of the Royal Swedish Academy of Sciences. So before we start our discussion with the laureates, let me first say a few words about our academy, the Royal Swedish Academy of Sciences. Our main objective since 1739, it's quite impressive, is to be a strong voice for science and particularly for basic science in the society. And we work hard to influence research, policy, priorities, with a focus to improve basic science in this country. This year, our academy was pleased to learn that the Swedish government, in its research bill, significantly strengthens its support for science over the 4 years to come. And this is good news, and the news are not the same for the rest of Europe. But despite a good funding climate for research in this country, Swedish science in the top league is not performing as well as in some other countries. There are, for example, fewer highly cited publications from Sweden compared to a research-intensive nation such as Switzerland. So in a few days to come, our academy will make it public a report that is analyzing this Swedish dilemma. So that was just an advertisement. So let me now introduce the laureates. Closest to me, we have the laureates in physics, and the Nobel Prize in Physics 2012 is awarded for groundbreaking experimental methods that enable measuring and manipulation of individual quantum systems. And the laureates are Serge Haroche, Collège de France and École Normale Supérieure, Paris, France, and David J. Wineland, from National Institute of Standards and Technology and University of Colorado Boulder, USA. And in the center, almost in the center at least, we have the chemistry laureates, and the Nobel Prize in Chemistry 2012 is awarded for studies of G-protein coupled receptor, and the laureates are Robert J. Lefkowitz, Howard Hughes Medical Institute and Duke University, and Brian Kobilka, Stanford University School of Medicine at Stanford. And to my far right, we have the laureates in economic sciences. The Sveriges Riksbank Prize in Economic Sciences in memory of Alfred Nobel 2012. And that was awarded for the theory of stable allocations and the practice of market design. And the laureates are Alvin Roth, Harvard University, Cambridge, and Harvard Business School that we have here on the podium, and Professor Lloyd Shapley, University of California, Los Angeles, who is not here today, but we can sure rely on Professor Roth to answer all our questions related to market design. Well, since early October this year, when I called and told our laureates about their awards, I'm sure that they have got one hell of a number of press conferences, interviews, and questions, and basically you have answers for everything and almost any questions that are imaginable. So let me now approach you, and you're free to pose the questions to the laureates. And I start directly. Perhaps first I tell you that introduce you with your name and the media, and also please use a microphone because this is on video. So please, Karin Boys. Do we have another microphone, or we can turn it on? We have another microphone here. Du kan komma runt där, perhaps.
Now?
Yes.
Now you can hear me, thank you. So I'm Karin Boyce from the Swedish daily Dagens Nyheter, and first of all I like to congratulate you for the prizes. And I have a question for the 4 laureates in physics and chemistry, and for all of you. How did the school system in primary and secondary school took care of your particular personalities and gifts? And from those experiences, are there any lessons to be learned for today's school system?
So who is prepared to start answering that?
Well,
Professor Lefkowitz?
I had an interesting experience in high school. I went to school in the city of New York, and there's a series of special high schools. There are several that cater to people interested in the sciences and mathematics. The Bronx High School of Science and another one called Stuyvesant High School. There are schools for people interested in the arts. There's a school called the High School of Music and Arts, etc. And these are public schools and are open to anybody, but admission is based on a competitive examination to show at least some proclivity in the area that you're interested in. For example, if you were interested in going to the School of Music and Arts, you take an exam, but then you have to either present examples of your artwork or your music or whatever. So I went to the Bronx High School of Science, where the program was very enriched. I found it very stimulating. But it turns out that the Bronx High School of Science, which I think is 75 years old now, has graduated. I'm the 8th Nobel laureate. My 7 predecessors are all in physics and are known to my colleagues, some of them in physics. So I think one thing to consider is that model. Interestingly, in Durham, North Carolina, of all places, where I've lived for the last 40 years, there is now a North Carolina School of Science and Mathematics. It draws not just from a city, of course, as we did in New York, but from the entire state of North Carolina. Again, it's modeled on the Bronx High School of Science. It's open to anybody. It's a public school, but it's based on competitive exam. So this is something I think to think about in terms of trying to foster Bronx High School of Science.
Okay, we have some other experiences.
Yes. I think that the example that Bob just gave is a very special example. It's a very elite school, and it's clearly something which cannot be emulated everywhere. But I think it's very important to develop the spirit, the taste for science in very young children. And there have been some programs which have been developed in the United States and in France to expose young children to direct observation of phenomena and very simple scientific and basic experiments in physics, chemistry, and biology. And I think these programs might be very useful just to put the taste of science in rather young children in elementary school. In France, one of the problems also is that mathematics are used as a way to grade students, and the elite students who are accepted into the best schools afterwards have to be good in math. And this has put a strong pressure on the students, and maths are getting less popular because they are used as a way of selecting people. And I think this aspect of mathematics is counterproductive. One should have an education which allows people who may not have a very strong taste for math to be interested in observational sciences, and I think this would be useful, an interesting way to go and a useful way to go. In general, I think one has to develop in society the taste for science and the way the scientific mind is working. I think the culture of science is not developed enough, and this has to start with schools, elementary schools and high schools.
Okay, thank you. Do we have some more questions?
Well, I would
You're pressing them. Please,
Right.
Brian.
Yeah, I think I could say that, you know, even at an earlier age it might start, because actually my son has started a school for very young kids, 3 to 5 years old, and he centered it around science. But as he says, you know, it wasn't so important that necessarily that they become scientists, but that they learn how to learn, that they're encouraged to learn. And coming back to your original question, in my own case, you know, I didn't go to a top high school, and I wasn't a top student, but I think, you know, certainly the thing that really made the difference, I think, was my parents were very supportive of what I did. So, you know, it can work different ways, but certainly in my case, it was my parents that were very supportive.
So I probably had an experience that was on the other end of the spectrum from Bob's. I grew up in a very small town in Minnesota, and there was only one school for all of us to go to, and there were no admission standards. We had to go to high school. But I think that what was very important for me is that I was very fortunate that the teachers who taught us physics, math, chemistry, biology were all really enthusiastic about what they taught. They tried to keep up with you know, with the standards of teaching and even just current science. They would encourage us to read popular science magazines and at least keep up with what was going on in the world. So for a small school for a small high school, even though it wasn't a magnet school by any sense, the teachers, I was very fortunate that the teachers, I think, were quite special, and their enthusiasm made a big difference in my interest in science.
Dr. Roth, do you have a comment from your perspective?
I also went to the New York City schools. I didn't go to as fancy a one as Bob did, but I understand I'm only the second Nobel Prize winner from my high school. But I participated in a program run by Columbia University for high school students. It was called the Columbia Science Honors Program, and we went to Columbia on weekends and took classes, and that was for me a very formative experience.
Thank you. Do we have some more questions over there?
Yes. Hi, my name is Louise. I'm from the Associated Press. First of all, I have a question for you, Mr. Normark.
Me?
I was wondering where Mr. Shapley is, first of all, why he's not here today.
He's not here today. Dr. Shapley is a little bit tired. He is, as you know, has reached impressive age. He's close to 90, so we're trying to make his program a little bit lighter than the rest of the laureates. But he will show up for the photo, we think, after this session and so on. But we will take a little lighter program for him.
Okay, but there's no need for worry.
No.
Great.
Not at all.
And then I have a question for Professor Roth. And it's actually about the world economy. I'm hoping you might be able to give us some insight. The fiscal cliff is a hot potato in the US right now, and people are hoping that a deal will be struck before the new year. But I was wondering, is the political brinkmanship doing permanent damage to the US economy by creating uncertainty?
Well, only time will tell whether the damage is permanent. Political economy is a tough subject. We're facing the end of a tax regime that was put in place 10 years ago with the provision that it would end suddenly. The anticipation was that this would lead to negotiation. One of the things we've learned by studying negotiations is they often have a strong deadline effect. Often when agreements are reached, they are reached very near deadlines. So I think it's too early to tell what will happen. Much of the action in negotiations happens very near the deadline. That doesn't mean that the action is always successful.
But do you think it's like dangerous how much the political agendas are like pushing the decision so close to the deadline? Is there a risk in that?
Well, I think that there's
there was some eagerness to structure it so it would seem like a very sharp deadline in order to concentrate the minds of our politicians and legislators. I think that in fact there's nothing extremely special that will happen on January 1st if they fail to reach an agreement then. It's not that the world will change in a day. It'll change in a month if government expenditures go down and tax rates go up as they will do if no agreement is reached. But it wouldn't be the end of the world if the agreement is reached on January 3rd instead of December 31st.
Okay. I just had a follow-up question, and then I'll share with my colleagues. The second one is about the situation in Europe. Do you expect the Eurozone governments to have to write off some of the loans they've given to Greece? And do you think the focus on austerity measures in Europe is still too strong?
Well, you're asking the wrong kind of economist those questions. I'm a microeconomist. And of course, I know less about the European economy than I do about the American economy. So I think that even though I've just won the Nobel Prize in economics, I'm going to avoid answering questions on which I have little expertise.
Thanks anyway.
Okay. Do we have another question over there? Wait for you to get a microphone.
Okay. My name is Chen Axelson. I'm a freelance reporter for some Chinese media. I also have a question for Mr. Roth. Your theory of, we talk about market design, and I'm a layman in economy, but it's still very interesting. You know, when you say market design, it means you mean the government to design or the experts to design the market, and then how much the government should intervene in this market.
Well, that's a good question because markets have rules, and sometimes the rules are made by governments and sometimes they're made by the market participants. So if you look at a market like the New York Stock Exchange, it has a lot of rules, and some of them are rules made by the stock exchange itself, and some of them are laws some of the rules are laws that you can go to jail if you violate, and they're made by government, laws against insider trading, for example, which are meant to give confidence to traders to come to the marketplace. So there's room for governments, and there's room for market makers to make rules. You know, in our political discussion of rules for markets is a little bit impoverished. Sometimes in the United States, when we have a political campaign, the discussion seems to be between politicians who believe that markets have no rules, and on the one hand, and on the other hand, politicians who believe that governments can regulate markets to do whatever they wish. And I think those are both sort of confused points of view. And the way to think about a well-functioning market is sort of the same way you think about a well-functioning piece of machinery. A wheel that rotates freely is one that has an axle and well-lubricated bearings, and a market that operates freely, that works well, is one that has rules that allow it to work well. And sometimes there's a role for government in helping to set those rules.
Okay, thank you. There are a number of issues that actually we discussed over the lunch that I'd like to come back to. And, you know, we are in each country, of course, trying to foster the best science. And the question is, how should that be done? And that's a question that I quite often get as a permanent secretary. What should a country do to get a Nobel Prize in this or that area? For example, what is your opinion? Should the funding system support a project, or should it support an individual? Or how should the funding system work to really foster the best out of the best in a certain circumstance? Do you have any opinion about that, Professor Haroche?
When I started my research, I was a young scientist in the 1970s. I was mostly funded on just for my research as a scientist, and I did not have to apply for any contract promising applications or writing asking for money for a specific application or for a specific results within a short time scale. And I think this is very important if you want to achieve long-term goals and have ambitious projects working. So then during the years which have followed, I have seen that the system is evolving more and more towards short-term contracts. In France, for instance, now if you want to get money for research, you have to apply either to a French agency or to a European agency to get money. I think that this trend is going too much towards contracts versus funding on persons. I don't want to say that it's bad to have contracts. In fact, what has saved the research in France over the last 10 years is that we have these European contracts, European programs, and ERC, which provide money to good scientists. But I think it's better to fund people that on what they have already achieved and trust them with trust that they will be able to go on doing basic blue sky research in the future. I think this is a very important point because the research needs time and it needs to build confidence. And for researchers to have confidence in himself or herself, they need to feel the confidence coming from the head of the division and the people who are managing them. So I think it's very important to have this kind of support versus the short-term contracts. But on the other hand, as I said, what you need is to have money. So if money does not come in one way, it has to come the other way. And the contract money is good now because the part of the money which is given as an umbrella money by the agencies has decreased a lot in France for many reasons. One reason is that the agencies, the CNRS, which is the Center of National Research in France, has to use most of its money to pay salaries. And the amount of money which is put in research is about only 15%. So if you have this small amount of money to give for research and most of the money in salaries, you don't have the flexibility and the ability to direct money towards the fields which are interesting. So we rely on contract money too much, I think, and the system has to be changed in some way.
Okay. There are some other comments.
Yes, I would like to very strongly agree with Serge. We have both types of funding in the United States. The NSF, National Science Foundation, the NIH, primarily give out money for individual, highly specific projects. And frankly, the emphasis is on safe or conservative projects because one has to provide evidence in the grant that what you're proposing to do is clearly doable. That is to say, you've really kind of done it already, at least in outline form. So it in no way encourages creative, innovative, breakthrough research. On the other hand, I've been fortunate enough to be funded by the Howard Hughes Medical Institute in the United States, which currently has about 350 investigators. And this is a very different model of funding, and one that Serge referred to, where the funding is to the investigator, not to do a specific project, but just funds for that investigator. Now, every 5 years, the investigator has to present what they've been doing and provide evidence that they have been a good steward of the funds that they've been given and have been successful in producing high-quality research, and give a rough idea of where one might be going in the program, and then it's determined whether the funding continues. But there's absolutely no requirement to pursue any specific goal over the ensuing years. And I think this does encourage more creative work, and individuals who either are Hughes investigators or who have been Hughes investigators have won quite a large number of Nobel Prizes.
So I think that the challenge in the United States and probably in Europe as well is deciding, particularly for young investigators, whether they merit this confidence to just give them funding and see how they do. And if that were the case, I feel that most of the young investigators coming from very highly productive labs would be favored over those who maybe didn't have the same quality of experience in terms of their graduate and postdoctoral research, but were nevertheless very talented. So I think there is no one no one right answer, but the challenge is to try to figure out how to support young scientists, and I probably will have to be a more creative solution than either just giving them money or having them write a very safe proposal.
I mean, clearly the investigator-oriented approach as opposed to the project is much easier to do for later stage investigators who have a track record. So you really kind of know what they can do. I think Brian is right. The real challenge is on the early side, when the investigator may have great potential, but hasn't really had the opportunity to display that yet.
We have, of course, we are celebrating a Nobel Prize, and so Nobel Prize are breakthrough discoveries, and there are always something ahead of a discovery, what is about to come, and of course there are a number of interesting points about the research that you have accomplished, and I'd like to ask a question that was asked during actually when we made it official that you got the prize, and that is particularly to our physics laureates, about the promise of studying, you know, elementary particles that you can do and really manipulate them, so to say. What is your sort of honest opinion about the prospect of a quantum type of computation for the future? Will that ever happen, you think? And if it happens, will it be in this century? And if it happens, how fast could such a computer be? Could you speculate that or give some opinions on that? Is it Dr. Wineland?
Oh, I could start. I guess, well, I've been asked this question before now, and I would say, well, don't invest in any quantum computer companies just yet. So,
that's a good advice.
I think there's you know, there's maybe some confusion. People always think of this computer as being very fast, and that's it's in fact it's a little different statement. It can, if we can make it, it's extremely efficient. But it's only efficient at certain problems, so it won't replace, or it's extremely unlikely it'll replace the computers we have now. The other thing to say is I think that right now the field is in its infancy, and to give you an idea, we can make little tiny quantum computers, you might say, but they don't do anything that we can't do simulate on a normal computer. But I think more importantly, so what it'll take if we can make this big general so-called universal quantum computer, it'll take a lot of technological advances, and you mentioned that part of the work we're cited for is to have control over quantum systems. And to realize a quantum computer, we're going to have do much better than we do now in terms of this control. But I actually feel I'm optimistic. You ask when. You know, it's hard to say, but I think it's still quite a ways off. On the other hand, I think a lot of work in physics is devoted towards, whether it's quantum computers or some other technology, it's towards better control of the systems we work with, and typically that means at the quantum level. So in the long term, I'm actually fairly optimistic that we'll have a useful device, but I think it's still too early to say when.
Haroche?
Yes, about 15 years ago, we had, Dave and I, a friendly controversy about the quantum computer. I wrote a paper, an opinion piece with my colleague Jean-Michel Raymond in Paris called "The Quantum Computer, a Dream or a Nightmare?" with a question mark. The dream is, of course, to get this device working, and in fact, in principle, quantum physics tells us that if you are able to control particles at a large scale, many, many particles together, then you would be able to do some tasks and to perform some algorithm much faster, much more efficiently than in classical computers. So this is the dream part, the theory part. Now, when I refer to the nightmare, and of course we were a little bit provocative, nightmare is a nightmare for experimentalists because they have to be able to control things with a level of precision that we are far from achieving now. The controls that we are doing in our experiment and in the experiments that other people are doing all over the world now in the field called quantum information is that Dave said we are controlling a few particles and we are demonstrating the fundamental logic of the quantum world, which is quite counterintuitive for our classical minds. But we are very far from building the device, and what I wanted just to warn against in this paper, and I think it's still true now, is that it's much too early to present this quest for the quantum computer as a kind of applied physics technological achievement, like the Manhattan Project, for instance. When people wanted to build the atomic bomb, all the physics were there. It was just a matter of putting enough effort in it. Here, it's completely different. We are still lacking some important missing points. We don't know what is a good candidate for a quantum bit. We don't know how we can scale things up to the levels that we need for the computer to work. So I think, and then I'm sure that Dave and I will agree on that, is that we are trying to answer challenges as they come, to build things from the bottom up as well as we can, and we are confident that something will come up. It might not be the computer that we are thinking of now, but it will be something else which might even be more exciting. And I want to say that all fundamental research is going that way. The people who do the fundamental work in general don't know what it will be applied to, and if you ask them what is your research will be useful for, most often they would be wrong in answering that question. It was the case when the laser was invented. What the inventors of the laser had in mind is completely different from what the lasers are doing now. And I think it will be the same for the control of particles at the single particle level.
Mm-hmm. Thank you. Boys?
Well, yes, I was wondering if you, beside your work, have any interests, any hobbies like physical exercise or music, and something you do except working?
Sorry, I didn't understand the question.
If you do something except working, I imagine that could be a bit in your spare time.
Oh.
If you have some kind of hobby or interest.
Me personally, I guess I'm very into physical fitness. My whole basement is actually equipped as a gymnasium. I think this is in response to the fact that, as Brian can attest, I'm totally devoid of any natural athletic ability or talent. So I work hard to keep myself in reasonable physical condition. So I have a treadmill, I have an elliptical machine, and 2 different types of stationary bicycles and a universal gym, which, much to my wife's displeasure, now occupies our entire basement. So that's one hobby. The other is reading fiction from time to time. But I must say that in the roughly 2 months since the Nobel announcements, I was halfway through Don Quixote, which, as you may recall, a 1,000-page novel. I was on page 500 when you called me, and I'm still on page 500. But I am hoping to get back to that at some point.
Okay, you have some more comments on that?
Well, Dr. Roth? Since moving to California and enjoying the good weather there, I find I enjoy riding my bike to work and home again. And I live on top of a big hill, so there was some question about whether I'd be able to get home. But so far, I've gotten home every night.
Since my colleagues put so much emphasis on physical fitness, I would like to recall what Churchill answered when he was asked about his longevity and health. He said, "No sport." So I am on this side. I like walking, but I don't make any special efforts. But I I like art. I think one of the privileges of our work, of our job, if I can call it that way, that we are traveling a lot, maybe too much, but we are visiting a lot of places, and each time I am in one of these places with my wife, we like to go to museums and to see all kind of art, painting mostly. And I think there are some connection between art and science, and I am fascinated by the fact that the big revolutions in science have been very often, occurred very often at the time when there were also big shifts in art. I refer, for instance, to the beginning of the century when the quantum revolution started. It was a time where there was a secession school in Vienna, or the expressionist painting in Germany at the time of these big upheavals in science. Of course, the Renaissance in Italy also was a period where art and science had big changes together. I don't know what we could say about today, because I cannot follow the developments of arts today. Maybe I'm too old for that, but I think science is ahead of arts today, but maybe I am a little bit biased.
Okay, question there.
My name is Steve Steinberg. I'm the producer of an interview series in New York City called Dazzle Unlimited. It's a science technology series. I have two very separate questions. One is for everyone up here. What would you recommend would be the way to build public understanding and support of the need for scientific progress in general? And my other question is about quantum computing. This is a little more specific. I've read that, I don't recall if it's the Defense Intelligence Agency or the CIA, but some agency of the US government is reportedly constructing right now a giant computer facility in Utah, which I've read is based on or will be including quantum computing to track and analyze just about everything digital. So I would like the two Nobel Prize winners in physics to please comment with any thoughts on that. So those are my two questions.
If CIA is the issue here, I think I will ask Dave to answer.
If I tell you, I'll have to kill you. No, actually, I must say I hadn't heard of this thing in Utah. I hadn't heard anything about. So maybe you have some special inside information. But seriously, I would kind of doubt what you said about this in the sense that I think certainly the intelligence community is interested in this quantum computer. One application that's often talked about is if we could build a large quantum computer, it would have important implications for the security of encryption. It basically could crack all secret coding that's done now. But I think, in spite of their interest, I think since the dust has settled over the last 15 years, I think that the people that are funding this research, they realize that it's an extremely hard problem. And they want to be interested, and they are funding a lot of the work, certainly in the U.S. But I think they're, for the most part, very reasonable people. They realize this is a very long prospect. So I hadn't heard about this situation in Utah, and I would find that really strange if that were true, what you said.
But it's true that there are some private companies which are claiming that they are building a computer whose achievement, whose performance now is much better than all the published papers. And as Dave, I doubt it very much, because I think if there are good results and serious results, they should be published in papers that other scientists can check. And we cannot check at all what they are claiming, and it seems very dubious.
Question there? Yeah, you had a second question. Can you repeat the second question?
The second question was the second question for everyone in general. What would you recommend should be the ways to promote public interest and support in science, the sciences and scientific progress? And I guess from a political standpoint too. I mean, One of the things that you've talked about is what's involved in getting proper support for your pursuits. Is there something that should be done in general that you would suggest overall to help boost the sciences and the public awareness of its importance?
You know, it's something that that's certainly a problem we haven't solved in the United States. But I have to say that seeing this Nobel Week play out in Sweden is a very impressive public outreach about science. To see a country devoting a week to, talking about science on television and spending the attention being given to scientists this week is quite something to see. And I wonder whether that's a model that might be followed elsewhere to try to inform the public about science. During the time when the U.S. space program was very active, science was entertaining in the United States, and I think that helped outreach about science. So it's something that the scientific community should certainly be thinking about, because to the extent that we depend on public support, we should be prepared to talk more to the public than perhaps we do.
Maybe I could add, I can turn the question back to you. What the media, can do to improve the way science is perceived in society? I think, at least when I look at it on the French side, I think that a lot of things could be done. You could have public education by very high-quality science programs, which should be broadcasted at prime time, and this never happens. And when there is a discussion about science, usually it's a kind of talk show when you put against each other one serious scientist and someone who has very outrageous claims. For instance, an astrologue, or some people who think that there is no global warming, against someone who is explaining clearly that there are proofs of global warming. So they try to build up some kind of dramatic discussion instead of a serious discussion about the issues. And I think it would be very important to develop the need for science and the understanding for science, but this requires media and television programs which are not obsessed by getting a large audience and money, but which want really to promote science in society. But I agree with you that the goal is extremely important. We are facing issues which are very, very important for mankind in the years to come. And to solve this problem, you need to have a scientific mind and to raise the question in the right way. And this is not the way it's going now. There are a lot of countries where there is a lack of confidence in science. This morning we had a meeting with Nobel Laureates in biology, in physiology, and the Japanese laureates said that since what happened in Japan last year, the nuclear accident, there has been a dramatic decrease in the trust in science and scientific people in Japan. And to some extent, I think it's true throughout the world. And we have to do something against that, because we have to reconcile the public with science, and the politicians have to understand that the society needs more science.
Can we have a question? Oh, yeah, you had. Okay, sorry.
Thomas von Heine, Swedish television, the public service channel. I have a question for Doctors Haroche and Wineland. When you mentioned earlier, you said quantum physics are counterintuitive, and they are. They're completely against everything we see around us. When you meet school children, if you do, or younger people, do you have anything that you usually say that will sort of open their eyes and minds? So that's what it's about.
Well, I think there's this was cited or listed in the citation. We talk about Schrodinger's cat, and one way to at least for young kids and non-scientists to talk about this is I use the analogy of one experiment we can do on the small scale is that it's like we put our ions in what we call a trap, and what you can think of, it's like a like a marble in a bowl, and the marble rolls back and forth. And the exciting, the strange part of this quantum world, we can make the situation where at some instant of the time the marble is both on the left side of the bowl and the right side of the bowl at the same time, and not one or the other, it's both at the same time. And so, I mean, I think it's a difficult thing even for physicists to kind of train your mind to think this way, but this is the world we live in. I think, as I say, when talking to young people or non-scientists, it's, giving an example like that, I think stimulates most people's interest. Why does this happen? And so that's one way to introduce it to people, I think.
But I think it's not that different from what you have to say if you want to explain it to grown-ups. It's the same counterintuitive issue. But I agree that the Schrödinger's cat is as, I would say, as popular as maybe as the cat in Alice in Wonderland now. So it's trying to make a nice story and a metaphor about that to explain that this world obeys to Stange's law. I think maybe you have to turn the question around. If everything is quantum at the bottom, how come that we don't see it in our world, which is made of atoms and photons and things like that? So the big issue is not why is it so strange, it is why is it not strange at our scale? And this is the issue of decoherence, how the quantum weirdness disappears, is washed out in large systems. And this is the kind of things that both Dave and I are investigating. He's doing that with a few ions in a trap, and we in Paris, we do it with a few photons, but these are similar things. But I think that the big problem is how does it disappear? And another interesting question is that the people who founded the quantum theory 90 years ago were unable to do these experiments. And these counterintuitive ideas, they came to these ideas by just seeing very indirect effects. The properties of matter and radiation at the scales they were able to observe did not exhibit directly this weirdness, but by mere deduction, they came to the conclusion that that was the way matter should behave at the atomic scale. And they did not like that at all, exactly for the reason that you said. They did not like this counterintuitive aspect. Einstein and Schrödinger never believed that it would be the end of the story. And what I found absolutely fascinating is that in spite of the fact that they did not like it, they were forced to come to that conclusion. And these were real scientists. They observed things, they came to a conclusion, and even if they did not like the conclusion, they stick to it.
My name is Corina Negra. I'm coming from Radio Romania Science Department, which is the national public radio. I have two questions for all the laureates. First of all, I would like to ask you if you had any moment in your career when you said, okay, this is something rewardable with a Nobel Prize. And by the way, did you ever wish to get the Nobel Prize? And secondly, now that you won the Nobel Prize, what is the thing you would like to use your influence for? Is there something you would like to change using your new, let's say, position now? Thank you.
I know Alvin has a great story about the wishing to have a Nobel Prize, but I'll let him tell. I've heard him tell us before that he knew very early on he wanted the Nobel Prize, but I don't recall ever really thinking very much about it, even in my early days in Bob's lab, and I don't think many scientists become scientists because they want to win a Nobel Prize. I think I'll just end it there.
Well, thank you, Brian. So when I was in 8th grade, we had an English teacher who asked us to raise our hands whether we'd prefer to be President of the United States or to win a Nobel Prize. And so as I recall, I was in the Nobel Prize party. But since then, I hadn't thought about it very much.
I don't think many scientists at all are impelled by a desire to win the Nobel Prize. We were talking earlier, and I think for all of us, it's clear that what impels us is curiosity, just an inherent interest which you can't explain in some area of investigation, and I think we pursue that often single-mindedly. In my own case, I have never worked with an idea of winning the Nobel Prize. And in recent years, I mean, I'm almost 70, as I think some of my colleagues are, yeah, I'm certainly not in the early phases of my career, but people have mentioned to me the possibility. So sure, it does come through your mind, but I find it difficult to believe that there are many scientists who actually have that as a goal.
Yeah, I think I would agree that, that I suppose winning a Nobel Prize is certainly in physics, it'd be like the football team winning the World Cup, or, and so about this, and sure, it may be kind of a dream for us, but I think but I think we would all advise anybody interested in science or economics, whatever, not to go into it for that reason. You have to like the process. I think the real reward is being able to work every day with the kind of the things we work with, and I think that's what really motivates us in the long term. So.
Yeah, I agree with all of what has been said. I think the first question you ask is what were the high points in your career? What were the moments where you were very happy about what you have observed? And I think this happened, for me, it happened 3 or 4 times. I did an experiment, and I was very excited about the result, and I thought, oh, this might be of interest to other people, and this kind of happiness is the highest a scientist can have, to find out that he has observed something which he was looking for a very long time, and then it just appears in front of his eyes, so to speak. Often it's something that you predicted, but it was very difficult to observe, and this is good. It would be even better if it's something that you did not predict and came out of as a surprise, and this happens for some scientists, and it might be an even bigger joy for the scientists who experience that. But I think the real pure joy is when you get with your colleagues and with your students this feeling of excitement coming from the discovery. Now, the other question you ask, what are you going to use your prize for? I think this press conference gives an answer. We had to answer some very important questions about the connection between science and society, questions about what should be done to improve research and to improve the efficiency of scientific research in various countries. And I think these are very important issues. And on these issues, I think that the fact that we are put in front of the media should give us an advantage to be able to push these issues. But what I would like to avoid is to answer questions outside my field, and which might be a temptation, because when you get this prize, I discovered that during the last 2 months you are asked a lot of questions, and whatever you say is supposed to be the truth. And I think I can warn you against that. It's not true, but I think if it's in the field that we have been working on for many, many years, and as has been recalled, we are getting rather old already. We have an experience in this field, and I think what we say there, if it might make a difference, then it will be useful.
Okay, do we have I think it will be the final question, actually.
Okay, I actually had 2, but I'll try to keep
them
very short. First, for the physics laureates, you said that most people are wrong about what quantum computing is about. So I was wondering, or like the future will tell what it will actually be used for. So I was wondering if you could tell us, what do you think will be the main application for quantum computing in the future?
Well, I have a hunch, and actually it isn't my idea. People were thinking about the ideas of simple ideas around quantum computing in the 80s, and one notable person is Richard Feynman, another physicist, and his idea was, can you, because to simulate quantum systems, it becomes extremely difficult the way the computational size scales with the size of the system. It's an exponential scaling. And so his idea was to, well, maybe you can get one quantum system to simulate or emulate another quantum system. And I think for most physicists, I think that's likely to be the first application, to be able to simulate some other quantum system of interest. And so I think that's where most of us hope for the real future. So this factoring machine, this code cracking machine, that's an extremely hard problem, but the simulation problem is still very hard, but I think that's much more in reach. So I think my feeling, some other people feel the same way, that the simulation problem may be one of the first useful applications.
Okay, and my second question is for whoever among you who feel like you want to answer this. You said that you doubt very much that most scientists get into the field or are motivated by Nobel Prize. But on that, so I'm going to change the question around. How do you think the world of science would have looked like without the Nobel Prize? Would it have been different?
You're asking, how do we think our own scientific?
No, more like the world of researchers and scientists. You said that you think that most scientists aren't motivated to get into the field because of the Nobel Prize. But on the other hand, if it didn't exist, would the world of science look differently? I'll just pick one. I'll choose you, Lefkowitz.
Okay. Yeah, I'm thinking that I'd like to believe that if one says, would we be less far ahead, more far ahead, if it wasn't for the Nobel Prizes? I'd like to think we'd be in the same place. That is to say that the Nobel Prizes do not feed back and actually influence the scientific process. I think what they do, obviously, is reward the scientific process, and they play a tremendous role in bringing scientific progress to the attention of society, which is one of the main things we've been talking about. I think all of us, I personally marvel at what goes on here in Sweden with the public awareness of this week and these activities. I've been stopped in the lobby of the hotel on one occasion already by somebody who just was not involved in this at all, but who had some questions for me about it. Who had been reading the Nobel posters. So, yeah, I think that it's more at least for me, in terms of how it shapes public perception of the scientific process and enhances public appreciation of scientific progress. I think that's much greater than Sweden. I mean, it's obviously throughout the world. There's not any question about it. But I think it's very dramatic, certainly here in Sweden.
Okay, I think time is passing. It's 2 o'clock, so we have to stop this press conference. I think that if there were any photographers that wanted to come up here and take some photos of the laureates, it's okay. And otherwise, I thank you all for coming, and thank you the laureates for lively discussion, and thank you all. So I should mention also, of course, that we have the Nobel lectures tomorrow, the whole day. So it is in Aula Magna, and it's free, and we hope to see as many of you as possible on that occasion as well. So thank you very much.